Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, range sum of BST. So let us first read this question, then we will be going ahead with the constraints and examples and then about the coding part. Although coding is visible here, but okay, let me hide it so that you can think about the same that how we are required to do this question, then we will be going ahead with coding. Now here we are given the root node of a binary search tree and two integers low and high. Return the sum of the values of all nodes with a value in the inclusive range low and high. So the thing is that we are given with this low and high, right? And the binary search tree is already given to us. So as it is a binary search tree, so that simply means that it will be following this particular rule that whatever is our root. So whatever would be the left subtree, that would be basically less than our root, and whatever would be there at the right subtree, that would be surely greater than our root. So that's why we will be easily able to search in this particular range which is being given to us. So that's the thing we are required to utilize this fact that left is basically less than root and root is basically less than our right. So we are required to utilize this principle only, and according to that, we are required to sum up in this particular range. So that's the thing which we are required to do in this question. And this is the main intuition behind this question. And as we will be going ahead in this binary search tree, so the time complexity would be as per the height of this binary search tree, because at max it could be a criteria that our range lies something in between these things, means completely as the height of our binary search tree. So our height of the binary search tree is log n, but at the worst case scenario, it could also go in order of n. Also means if it becomes a skew tree, then in that context, our time complexity would become order of n. So that's why the time complexity here would be directly order of n, and the space complexity that would be order of 1. In that scene, when we will be going ahead, if we don't consider that recursive stack, but if we consider that recursive stack, then in that context, that space complexity would be order of n. In that case, when it is a skew tree, else it would be also order of log n only. So now let us first check about the constraint. I hadn't checked in, but the constraint would be in that manner only that uh, we can easily go ahead with that log n solution or n solution. Means any of this could work, right? So that's why the constraints are in that manner. Value of node could be 10 raised to power 5. Okay, so if we add up this 10 raised to power 5, then yeah, it will line the range of integer only. And all node values are unique. That is also another thing. So now let us go ahead the coding part for the same. So now let me first tell you the algorithmic thing. So first thing is that we will be directly checking that if our present node which is there means when we will be performing that DFS, so we'll check that our present node which we are taking that should lie in the range of low and high. This we will be checking. If it lies in this range, then what we will be doing, we will be directly doing answer equals to whatever node value is there, we'll do answer plus equals to that we will be adding to our answer. So this is the thing which we will be doing if this is the criteria there. And the second point is that if then in this thing only we will be checking that whatever node is there. So we will check that if uh, whatever at the left part of that node is there, right? So, and our node was basically less than our low, right? So, in that context, we will be now doing a DFS with our node left so that we can check for the other values, and low and right would be as it is, and same goes with the part for our node right as well. So, that's the thing which we are required to implement in the coding part. Now, let us go ahead with the coding part for the same. Uh, So here is the same. This is the full code. Now what we are doing here is this is our main function which was being given to us means with root, low and high. And here that a variable. I have taken this as global variable, else we would be required to pass it here as well in our auxiliary function. Now doing the DFS, then at the end returning the answer. Now in the DFS, we are checking that if node exists, means if node is not equal to null, in that criteria, we are first checking that if a node value is basically greater than or low, or even it could be equal, or a node value is basically less than high, or it could be equal to high as well. Then in that context, we are directly adding to our answer. So this is the first condition which we are required to check. If that satisfies, then we will add up to our answer. And if there is criteria that both of these conditions are not satisfied, right? So in that context, we will be checking that if our low is basically less than our node value, if that is the criteria, then in that context, we will be going ahead with the DFS for the same by passing this node left as the next node to our DFS, and then low and high would be as it is. Then if this condition is also not satisfied, right, if by chance, then we will be going ahead with this part that node value is less than high. We are required to check that. If that is the criteria, then we will be going ahead with this part means directly we will be passing that node right and then doing our DFS. So this is how we will be checking that if both of the conditions satisfy, then we will be directly adding up to our answer. And if either of also satisfied, then according to that only we will be passing a node to our DFS. So that is the thing which we are required to do here. And then finally, we will be getting our answer in this answer variable because of this line. So this is how we are required to do this particular question. A time complexity and space complexity I've already explained. So if you have any doubt, you could comment that out. And if you really like the explanation, please to like and subscribe to my channel. So this was all for today. Thank you.